Right. So as I said, Samuel, I've just informed Samuel to come for your second set of notes. For those of you that have secured the pack, and so you see Samuel at the end of the session. This is just a brief session, and I hope you guys are doing a lot of work on what I've been sharing. We need to move on faster with your course outline. I missed the time today. I thought your meeting was 11. Yeah. So the the internet is really not stable, but I know you can get it from the audio when I'm done and the audio visual. I think it's been fine. The we have gone that far to the point of we have studied conditional and I gave assignments. I'm not ready for that yet. So we want to see, okay. Okay, yeah. How do you construct this type of truth tables? It's quite important to like constructing truth tables for certain logical symbols. How do you construct truth table for them? Like truth sets and tautology. So we have talked about, okay, now we need to start the biconditional. We have done conditional. We want to do the biconditional. We've done conditional, we want to do biconditional. So this is the biconditional. But before we go to biconditional, a quick recap was on these ones. I said I can give you statements and tell you to write the converts, the inverse, contrapositive, and even the conditional statement you can write. So the law of contraposition. The law of contraposition, the conditional may always be replaced by its contrapositive without having its truth value affected. So that is the law. The law is saying this is what the a conditional, okay, and this is the contrapositive. So we can replace the conditional with a contrapositive. That's what it's saying. It will not affect because it's like just taking the inverse and then you negate. So it's the same. That's because of this truth table. So I know you can handle this truth table. You should know how to do truth tables now. I am quite certain you can do that. And so we come to biconditional. In the previous session, we took great care to point out that a statement P implies Q and its converse do not have the same truth values. However, it may be the case that P implies Q and Q implies P. In this case, we write that symbol. So another logical symbol that I have introduced is the biconditional. How do you do the biconditional? This biconditional is another truth table or another logical operator or a symbol I've introduced, and it's called a biconditional. So remember, you have the conjunction, disjunction, you have negation, you have conditional. Now it's what biconditional. These are logical operators we use in mathematics, and these are good operators that are applicable, and we can apply them when we come to Boolean algebra. You see how some of these things are quite useful. So that's the biconditional. So you have a truth table for biconditional will give you it is only true when the opposite is true. So you can work on the truth table for that. But look at it, true and true. That is true and true. It's biconditional. That is true. True and false. True and false. It's not biconditional. So that is false. False and true is what? It's not biconditional. So definitely it is false and false and false. It's true because they are biconditional. False and false is biconditional. That is, you have both sides having the same mathematics and in logic. So that is how we write a truth table for biconditional. So I want to pause and see if you guys, if there's any comments you want to make or you want to say anything. Is it okay so far as I've explained the biconditional? If it's okay, yeah. Shekhar Stevens, do you want to say something? Oh, I think we can hear. I cannot hear you. I'm Abdul Abubakar. I don't know if it's my mic or. Hello, Abubakar. Abubakar, can you hear me? Yeah, I don't know why. Okay, it's like I'm not getting good reception on my microphone. I don't know why. Yeah, I cannot hear you guys if you're making a comment. Let's see, what's the issue? Okay, so that is the biconditional. If you guys are hearing me, and then it's of no need, I just need to continue, and it's be on record. So that's the biconditional. This is the biconditional, and this is the truth table for biconditional. It's the truth table for biconditional, and so let's say statements: if P and only if Q is biconditional. Q if and only if P is biconditional. If P then Q and the converse is biconditional, and Q then P and the converse is biconditional. So that is how you write biconditional. Write the following. See, you write the following as one statement. If a polygon has 3 sides, then it is a triangle. If a polygon is triangle, then it has 3 sides. So you can rewrite the following as one statement. Solution: a polygon is a triangle if and only if it has but 3 sides. So I have I have used this one if, but I'm using this now. So a polygon, instead of if now, no if in the, if you ask to write this, one statement, a polygon is what? A triangle. A polygon is a triangle if and only if it has 3 sides. Because it says if a polygon has 3 sides, then it's a triangle. So a polygon is a triangle if and only if it has 3 sides. These are ways you can write the conditional or the biconditional for some statements. So we move on to tautology in the truth set tautology. Okay, the set of logical possibilities for which a given statement is true is called truth set. If its true set is identical to its universal set, then the statement is logically true statement and is called a tautology. This means that a compound statement is a tautology if you obtain only truths on a truth table. So that it's a tautology. If you obtain only truths on the truth table, it's a tautology. See, for example, look at this truth table. I know, look at there. You have what? True and true, false and false. True, false, true, false. True, so if you're combining them using what? Disjunction. So true and true is true. That is true or, yeah, because it's disjunction. It's true, true or False is true, false or true is true, and false is false. That is for disjunction. So you just need to understand the respective operators or the connectives in logic. You can do some very good work with logic by combining, and also writing truth values for a lot of logical statements. So here it's the negation of Q. So when we negate Q, you have false, this becomes true, false, true. Then the negation of Q implies P. This is conditional. So look at it. Q false true is what? It is true. True false, remember in conditional is what? True. False true again is true, but true false is false in conditional. So that is why you have, I'm taking from Q to what? Q to P. That is what I'm saying now. Look at it here. False, true. Is true. True is what? It is true. False is true. And what? True, false is false. That is basically how you negate conditionals, and it's quite good. And now you now combining this implies this. So that is it. That is the conditional. True and true is true. True and true is true. True and true is true. False and false is true. So all of you can see that the final column of the truth table. This is the final column. I have this is 1 column, 2 column, 3 column, 4 column, 5, 6. And so also because you're learning some of these ways of working with logic, these are how we normally create tables, like when you'll be doing your advanced studies in statistics, when you want to like collect information and like. So you create tables like this, and then this could represent different records. You can do it for what? For thousands of records, or tens of thousands or millions of records. It can work using softwares and applications. So here we have the final table of this truth table there. Is what? It's all true. And for that reason, we say it is a tautology. It is a tautology. I don't know if guys have questions to ask, or let me just continue. I hope it is understood and everyone is hearing me loud and clear. Is that the case? Joy, do you have anything to say? Excuse me, let me change it. Is it okay? I don't know. Yeah, I'm having some problem with my earpiece. I don't get, I'm not hearing you guys clearly. This is the problem. I don't know, but if you guys can hear me, it's fine. It was working. I don't know. Okay, and it's on record, so I'll listen to the recording and then see. I'll share it out to you guys, and so that's the most important thing. Yeah. So that is your tautology, and so the next aspect is you have to prove. Look at the truth table. You asked to show that this truth table is a tautology. This one is a tautology. So have you seen what are the operators, or what are the statements I have? I have two statements here. One statement is P, another statement is Q. And they have been combined by what? operators. They have been combined by operators. Okay, so one of these operator is this is the conditional. This is also this we well there are aspects. Let me just explain that one is quite